Okay. Muy buenas tardes a todos de parte del Comité de Estudiantes de Ingeniería Mecánica CIM y de la División de Blog y el canal de YouTube. Mi nombre es Santiago y junto a mi compañero Kevin Murillo tenemos el gusto de contar con hoy con el ingeniero automotriz Jerry Lavine. Kevin, ¿cómo te encuentras el día de hoy?
Bien, Santiago. Good afternoon, Jerry. How are you? Thank you for giving us this opportunity to have you here with us.
Thank you. It's nice to meet you both.
Okay, de ahora en adelante la entrevista se va a llevar a cabo. I'm glad to introduce Jerry. Jerry, tell us, how are you doing today?
I'm doing well, thank you. Thank you for the opportunity for the interview. It's been a busy day with work.
Yeah, I do understand that your life must be very busy with all the automotive work. So we're going to start with some questions about your career. So
Sure.
if you can tell me, when and at what age did you decided to study automotive engineering?
Right. So I think I always wanted to be an automotive engineer from probably when I was a child. I always liked cars. I liked working on cars. I had an interest in mechanical things. So I knew I wanted to be a mechanical engineer, and I knew eventually I wanted to be a mechanical engineer in the automotive industry.
Okay, Jerry, that's perfect. I think that everybody that's studying mechanical engineering has have this passion for cars, and
For sure.
yeah. Another question is, what were the main challenges you had before and during your?
So I originally graduated from college in 1991, and in 1991, the job market was very bad. So it was very hard to find a job, let alone a job in automotive. So I decided to go to graduate school, and then I was in graduate school for 2 years. And when I came out of graduate school, the job market was much better. So then I was able to get interviews in automotive, and I was able to get the job that I wanted. I went to work for Ford Motor Company as my first full-time job, which was like my dream always growing up, right, to work for a company like Ford. But the big challenge was that I extended my college career by 2 years to get my master's degree, not because I really at the time wanted to get my master's degree, but because the job market was so poor that I couldn't get an interview with anyone in 1991.
Oh, I see. That must be like a real challenge. And another question is, today's market for a job opportunity, how is it today?
I think the job market now is better because it's there's so much changing in the auto industry. There's parts like in cars becoming autonomous. There's cars going from gas to electric, from battery electric to hydrogen fuel cell. There's a lot of different startups. So I think the market's going through a big disruption, and with the disruption, it requires new talent, and with new talent creates different job opportunities. But it's also made it now that before a lot of people that came into automotive were mechanical engineers. Now a lot are electrical engineers, or electromechanical, they're computer science, they're programming, they're materials. So it's also diversified the people that come into automotive.
Yeah, that's very interesting, and that leads me to the next question, which is the process to enter a company on automotive, such as Ford or Nissan?
Sure. So I think the one thing is to try to have like some sort of relevant experience, or some way that you can try to find what your entry point is. Like a lot of the companies, Ford Motor Company has a training program that when you come in out of college, you rotate around for 2 years, you see 4 or 5 different places. So you can come in as like a trainee, even though you're an engineer, but you're going to rotate to find out where you like the best, where you do the best. And the other thing would be is maybe if you knew, like if there's a specific area you're interested in a lot, if you're interested in like controls or electric motors, maybe you don't go to work at the car company, but you go to work at the tier 1 supplier that has that depth of expertise, right? They provide the electric motors for many different OEMs. So you would want to kind of try to see if you know what you want to do, you could become more focused. If you don't know really what you want to do, then you probably want to go to a company that's big enough that it could allow you to see different things and figure it out.
Okay, Jerry, I have this question for a person, well, for an engineer that does not have any experience working on automotive. How does he get an opportunity to get into these companies?
Yeah, so one of the things I did, like for me, I was a mechanic for the state police actually when I was in college, which isn't really the thing that helped get me the real experience that I needed to get into grad school and get the job. But I went to my professor. I liked my statics professor a lot. I liked my dynamics professor. So I went to those professors and asked them what research were they doing, and could I volunteer my time to work in their lab to get some experience. And that's what I used to build up my resume as my professional experience. So even if you can't get a paying job, you need to make the investment in getting the experience. And I'm guessing all of your professors, if you went and said, what are you doing in your lab? Can I volunteer 2 hours a week, 4 hours a week, 6 hours a week, some amount of time to do free work for them and learn about whatever they're doing? You could use that to build up your resume, and then you get work experience, even if it's not actually paid. And eventually it'll lead to being paid. So make the investment in getting the experience.
Okay, Jerry, I get this answer sort of like advice for us as students. Sure. to be like in contact with our teachers and be involved in different kind of projects for us to be in touch with the market and the automotive market. So the next question is, how many years of work experience do you have, and what significant lessons have you acquired for your life?
And so I've been in automotive basically my entire career. So in 27 years, basically, I think I'm going on almost 28 years in June that I've been in automotive. And I think the big thing is that to make sure that whatever you do, make sure you enjoy it, because it's important. You're going to spend so much of your time. And if you work in automotive, it's not a 9-to-5 job. The people that do well in automotive, they work a lot of hours. It's also part of their personality. It's a part of their lifestyle outside of work. So make sure it's really something that you enjoy. Make sure that you keep learning, right? I came in as a mechanical engineer, and now I work on things that are mostly non-mechanical, because I've gone, as I've worked my way up to different levels of responsibility, I'm doing system integration. I'm working on electronic modules. I'm working on hydrogen fuel cell vehicles now, batteries, things that I was never really formally trained. So make sure you continue your education. And then I think the other thing is, for my personal belief is, you want to get as close as you can, as early as you can in your career to the product. So my first real job at Ford Motor Company that was full-time was in the plant. I worked in an assembly plant. I worked probably 12 hours a day, 6 days a week for a couple of years, but I got to see how a car is really built. If you're an electrical engineer, make sure you get closer to, like, you engineer the subsystem or you engineer the parts. If you want to be an engineer, don't start your career doing like program management of that. Make sure you go into something that's going to help you develop like deep expertise, deep knowledge in some area, because then you can always move up later. If you try to push too hard to move up before you have that foundation, you won't go as far in your career long term.
Yeah, that's very interesting, Jerry. So basically, it's about don't wasting any time. You have to learn what you're going to use in your professional life. That's right.
Yeah, so you want to make sure you make a commitment to it, right? And your job will always make a commitment back to you, but make sure you also take ownership of it, because at the end of the day, no matter what company you go to work, no matter what training program they have, or if you have a mentor or anything like that, you really own your career, right? The company doesn't own it, you own it. So continue your education and make sure you develop some sort of expertise that if things go bad, right? Because the auto industry always has good days and has bad days. You have to have some sort of foundation to fall back on, right? So my background would be, I was in a plant, I was in body engineering for probably the first 12 years of my career. So when it comes to developing mechanical systems and taking them from a concept to production, that's my expertise. Since then, I've gained all these other things, but if things ever go bad, I have that foundation to lean on. And I've known that all the way through concept development, to developing specifications, to doing the detailed design work, to doing the validation, to putting it in production, to seeing it when it's in production, if it goes well or doesn't go well. And you just need to know those types of processes. And now I can take that knowledge from a body stamping or a seat or a piece of trim, and I can apply it to an electric motor, because even though it's a different subsystem, it's still the same process. So make sure you go deep and you understand really what the process is for something in the area that you care about, because it'll come in handy 20 years later when you're sitting in a review or you're a part of something that's nothing like what you've done before.
That's very impressive, Jerry. So with the pass of time, you have learned to adapt to every situation in the factory. You can basically learn things quickly because that's what is required for the job. Um, Another question is, what changes are taking place in the automotive industry to migrate to environmental impact of automobiles?
Sure. I mean, when I first started, right, people didn't care as much about even like simple things like packaging. Things that came into the plant came in cardboard boxes, and then sometimes they'd recycle the cardboard, maybe they wouldn't. Now they use reusable dunnage. People didn't care where the raw materials came from. Now they care about where do the raw materials come from, and do they come from a mine or a country that's environmentally and socially responsible or not. So there's much more of a concern for that. There's before, you didn't advertise how much of the vehicle could be recycled or what % of the vehicle was recycled content. And now there's big pushes to do those types of things. People want, we always push gas powered vehicles to emit as low as possible, right? The emissions was as good as possible. But now battery electric vehicles, and then batteries are good because there's no emissions, but you got to look at the battery and what raw materials are used in the battery. And are those raw materials actually mined in an environmentally safe way? And then at the end of the life of the battery, what does the battery do, right? It can't go in a landfill, so you have to look at its complete life cycle. So people are looking at much more from raw material to grave than they ever did before. And they're looking at it from cost and like total cost, right? So what's it cost to mine? What's it cost to put into the mold in the application? What scrap does it have? And then what's its end of life? Can it be recycled or can it be reused? So all those things were not considered near to the degree they are now. And companies, right? People will buy products because those companies are more environmentally and socially responsible, and they'll pay more for it. Before, I don't think customers really, that's not what they cared about when they bought a car. It was just, was it fast? Did it look good? Now they also want it to be responsible.
Yeah, I do understand the part of saving the environment, and today is more important, not just because environment as it, but saving money. We all know about the scandal of Volkswagen, the thing that happened with the emissions. There was
Yep.
a very big situation that it was that shocked the world. I mean, and that led me to a personal question. Do you think that internal combustion engines are going up the market?
No, my personal opinion is that there will be for a very long time a place for an internal combustion engine. But I think that the majority of the vehicles probably in the next 10 years will transition from gas powered to some form of electric. And it could be battery electric, it could be hydrogen, but it'll be some form of electric vehicle. And less than a third of the vehicles will probably be gas powered. And then that gas power will probably drop off, but it will never go to zero. There's some places in the world and some applications that a gas powered vehicle makes complete sense and is probably more environmentally friendly in the long term than a battery or a hydrogen vehicle.
Oh, that's very interesting to hear, because last year I heard a news that said that in the UK internal combustion engines were going to be forbidden since 2030.
Yes, so there's a lot of governments that have said that, right? And there's a lot of car companies. GM said by 2035 everything will be electric. Ford, I think, announced by 2030. So, but there's some companies that haven't. And I don't think right now all customers want non-gas powered cars, and somebody's going to make what people want. And there's a lot of technology that's still available in gas powered cars to make them more efficient. There's a lot of manufacturing capacity to make them low cost. Not everybody can afford a zero emissions vehicle. That's a luxury, right? To be able to afford something that is a battery or a hydrogen fuel cell vehicle. So people want transportation, and it's going to take a long time before it really goes away. Even though, GM will say that they're going to go away by 2035, but there will be some other brand or some sub brand that's still going to make a gas powered vehicle for some market.
Okay, Jerry. So, oh, sorry. I have a question. Is it true that electrical motors have a 0% of emissions? Because I've heard this news that said that they still have carbon dioxide emissions.
I don't think that the actual vehicle itself has carbon dioxide emissions, but the manufacturing process to produce it does have carbon dioxide. So that's where I think people now taking like a look all the way from the mine or the well to the end of the life would say that in some cases for hydrogen or for a battery electric vehicle, if the hydrogen or the battery is not mined properly, if the manufacturing process for the steel is not done in an environmentally friendly way, that there's still CO2 that's created from it. And that's why you need to look at the whole life cycle to say that you're really making the overall right decision, right? So how do you make the electricity, right? If you make electricity by burning coal, it's not a really clean process. If you make it by a renewable source and the materials are mined correctly, right, or from an environmentally friendly source, then it is a very clean process, but you can make it clean or you can make it dirty.
Okay, so it only doesn't depend about the car itself, but the process where the car is made and the process of how you get that energy.
Correct. That's a big part of it, right? I think that's why you got to look at, you know, electric vehicle would be a great example that if you're burning coal to make the electricity, that's a big pollutant, right? Coal plants are typically bad for the environment. If it's nuclear power, if it's hydropower, if it's solar powered, it's very, very green. Gas-powered vehicles on a zero, they don't have zero emissions, but they have partially zero, practically zero PZEV emissions. The emissions is really clean, but how do you get the oil, right? Where do you get the oil from? How do you refine the oil? How do you process it? So you really got to look over the whole life and spectrum to decide what's cleaner or what's dirtier in which process.
Okay, Jerry. So, which are the industrial limits for pollutant in the production of cars?
I think the industrial pollutants really depends on the country of manufacture and then what you do with the pollutants, right? There's some pollutants where maybe you emit carbon, but you capture the carbon, and there's sometimes when it goes out the stack. So there's even paint's a good one, right? They used to use solvent-based paint. Now they use water-based paint. So what goes out of the stack can be environmentally friendly versus being non-friendly. And then steel, right? How do you make the heat to create the steel? And is it burning of carbon? Is it a burning process where you capture the carbon or you don't capture it? So each process has, its own environmental impact. And then there's country laws about what you can and cannot do. And sometimes there's regional laws and sometimes there's even city laws about, what you do with all the materials and how you have to reclaim them or reduce, how much you emit or reuse what you create.
So everything is about the process, in how cars are made. So in which areas of the car design and manufacturing process do you think there are still many innovations or improvements to be made?
I think there's probably a lot in almost every area. If you look at like materials, the vehicle's still mostly either steel or aluminum, and the vehicle could be steel, aluminum, carbon fiber, graphene, a hybrid of a plastic and a steel, but it could be a cast part, it could be an extrusion. So I think materials is one area where there's still a lot of development to occur. And then if the materials change, then the whole assembly process can be different because carbon fiber is not stamped, right? It's formed. And then the bonding process of how you put the things together. And then you get into a whole like energy management for crash and for durability. So I think materials is a big area for new development. And then I think on electronics, there's also a lot of areas for development because you have things like autonomy, and autonomy has to be 100% reliable or it can't be effective because nobody wants to be in a car that 99% of the time it doesn't get in an accident or 99.9%. When you drive 10,000 or 15,000 miles a year, if it's only 99.9% of the time effective, that's a lot of bad things that could happen, right? So electronics, the sensing, the decision-making, so the artificial intelligence has to go up a lot higher. And then I think also the services that are offered in the vehicle have to be looked at. Right before, right, it used to be a car got you from one point to another, but now cars have communication with the infrastructure. They provide entertainment. They provide news, weather reports. Vehicles can communicate to other vehicles to tell them if something's going on. Vehicles can monitor a driver's health if the driver's dozing off or doing something. So I think all the electronics also have a lot of areas for development. So I still think there's a lot that's going to change near term and long term. I don't think we haven't plateaued in any area.
Okay, so Jerry, it's very interesting to hear that there's a lot of work to do in the automotive industry for us students that maybe are planning to work on it. We can start to think of job opportunities.
Yeah, for sure. I think it for me, it's going through a big change now, but no one knows where it's going to end. Is it going to be battery electric, fuel cell electric? Is there going to be gas? Is there going to be diesel? Is there going to be some other power source? And then just the whole ability to bring in health and wellness, consumer electronics, defense technologies, all those things into the car, those weren't in there 10 years ago. And now people expect them, right? They expect emergency braking. They expect blind spot monitoring. They expect or want night vision. They want, you to detect if somebody's in the vehicle when you lock the door so you don't leave a child behind. So there's a ton left that still has to be done.
Okay, Jerry, I have one last question, and then I'm going to pass this session to my colleague,
Sure.
Kevin. In the last 10 years, which is the development that has impressed you the most?
Probably in the past 10 years is like the switch from everything was gas or diesel powered to now that, if you say you drive an electric vehicle, even though the volume is relatively low, the vehicles themselves are mainstream. So I think that's the big switch that 10 years ago, nobody would have ever believed there'd be a real electric car on the road. And nowadays, most of the cars that people talk about and get excited about are electric. So I think that's probably the thing that's impressed me the most. And then if I could pick two things, the other thing would be the passive safety, where ABS was relatively new, probably 10, 15 years ago. But things like emergency braking, right? If you're coming too close to somebody and the car can stop itself, if you're backing up and you shouldn't back up, the car's stopping itself, the car's stopping you from going into a lane if somebody's there. So those type of passive safety features that provide real world safety benefits and save lives, I think are impressive.
I think the same way. I mean, I'm very impressed right now, but by the Tesla software that drives the car by itself. It's very impressive seeing those videos on Instagram where the car drives itself. I mean, 10 years ago, nobody would believe that would be possible.
Yeah, I mean,
so
cars will park themselves, right? Parking themselves is like an easy thing nowadays.
Yeah, that's true. Do you think that in the future we will be able to sleep 30 extra minutes while being in the car to get to our jobs?
I think if you have a ride on a highway and you live in an area where the government makes the investment on the infrastructure, that you will be able to sleep in a car in that type of situation. I think it's going to be a little longer before I get in a car in my driveway. It gets me to the highway. It gets off the highway. It goes, navigates the traffic, and it drops me off at work. I think that's a little further off. But getting on the highway for a long ride and being able to take a nap, I think that'll happen within the next 5 years.
That's very impressive and mind-blowing, Jerry. So now I'm going to pass Kevin. So Kevin, the word is yours.
Hello, Jerry. Hearing that you talk about the stuff that you were talking before, you were talking, for example, about the automatic driving before. Tesla actually has something like that, but it has caused many problems, if I'm not wrong. Do you have anything to say about that?
Yeah, that's why I think like it's that 99.9% effective. And I think that's why it's going to be, 5 years, it can take you on the highway, but it can't take you in a city environment until it's truly 100%. And I know Tesla makes sure that their customers know that the driver is still responsible. And the problem is that even though the drivers are told they're responsible, they watch the Instagram video or they watch a YouTube video and they think they can read a book or they can do something. And they're taking for granted too much that the car is really, really, really good, but it's not 100% good. And I'm sure Tesla's I can only imagine how many millions of miles on the road, and being 99.99% isn't enough when you put somebody's life at stake. So that's why the driver, right, in any vehicle, they still say that the driver is responsible. But I think in 5 years, there will be areas on like a highway that the car will communicate with the road or the infrastructure, and you can go from that 99.99% to 100%. And the driver truly can then say hands off, eyes off, and do what they want. But right now, people are kind of pushing the technology further than it's been developed.
All right. Another thing you were talking about before is that in the future it's going to be a transition from electric from combustion, to electric. But how is it going to for the large trucks, heavy machinery that relies on using fuel?
Yes. So right now in the United States, there's a lot of the larger truck companies like Class 8, the full heavy duty on road truck companies that they're trying to go hydrogen, or if they have short runs that are within a city in a predetermined rate, they think they can go battery electric. And I'm now working for a hydrogen fuel cell company that we think we can do medium duty trucks that are hydrogen based, right? So you would fill up with hydrogen, the hydrogen would go through a fuel cell, you would create the electricity on the vehicle itself and then power the motor. So that's why my personal opinion is battery electric will take some segment. And for those that have a predetermined route, short route, not high speed, things that a battery electric vehicle is optimized for. And then a fuel cell hydrogen vehicle will go for vehicles that need a longer route. They have a varied duty cycle where they don't do as much stopping and starting, so they don't have as much regenerative braking and other ways to regen power. And that's why it'll be a split between those two. And I still believe though, right? I said I think 30% of the vehicles will be gas powered because there's going to be a need for some places where it's long haul trucking, where gas is still a really efficient way to move product in a big truck.
Right. Talking about that, what do you think are the innovations in hydrogen production inside of motors? Since I've read about it, and actually here in my university, there's a project about that.
So there's a lot of governments now that are making major investments in hydrogen. And I think the reason that hydrogen is something that a lot of governments want to look at because there's so many different ways to get hydrogen, and you can get it in a very environmentally friendly ways versus not as environmentally friendly ways if you get it from like natural gas. And every country in the world has access to hydrogen. So in terms of like material or raw material independence, you can be more independent as a country based on a hydrogen-based energy system than like a full battery electric, because battery electric vehicles are dependent on cobalt, they're dependent on lithium, and those raw materials aren't available everywhere in the world. For a hydrogen fuel cell, like the fuel cell stack, the precious metals, most of those things can be mined and be available anywhere in the world. They can also be completely reused. So when the vehicle gets recycled at the end of its life, the fuel cell can be reused back at 100% efficiency. It doesn't go down life cycle like a battery does. So that's why I'm an advocate that I think hydrogen fuel cell vehicles will take 20 to 30% of the market going forward.
All right. You also talked about the trainee programs that Ford and other car companies use. Do you think it's feasible for a student from another country to participate in those programs? And if it does, do you think they pay, since it's hard for a lone student from another country to go to another one without the means to do it?
You know, so I think that it's always hard earlier in your career to go from one country to another country to work. But I think that a lot of the global companies now, right, have regional engineering centers. I know Ford used to have a big regional center in Brazil. I don't know if it still does or does not. I know, but they've moved a lot of their engineering to be, they have some in the US and Michigan, they got some in Mexico, pretty sure they still have some in Brazil. They have a lot in China, they have a lot in India. So I think a lot of the global companies are decentralizing themselves. And I'm assuming in all those locations, they have some form of the same training program. So I think you'd want to start your career, it'd be easiest to start your career where it's easiest for you to legally find work. And sponsored immigration is typically expensive for a company. So they'd be reluctant to do it when somebody's just out of college, right? They would typically do it for the person has a special skill that they can't get locally. So they have to sponsor a person to come do it. But I think in almost every region of the world, the global OEMs have a presence. Volkswagen Group, Daimler, BMW, General Motors, Stellantis, Ford, the Chinese companies, JAC, right? They have operations in Brazil. So I think that you'd want to look in your region, because that would be most likely to be successful.
All right. Thank you for your answers. Also, you talked about you now are working also in the chip, the part of the electronic part of the car. You've heard about that. You've heard about the chip shortage that have happened in the workplace. I suppose you've heard also that, for example, I think it was Ford that closed some of its fabrics. Some of the places it made cars because it doesn't have enough chips to manufacture the cars. Do you think it will be a short-term thing, or it will affect in the long term the car industry?
I think it's going to have a big effect this year, right, on production, because it's affected almost every OEM. I think that what the OEMs are going to learn from it, though, is that as much as you have to have the right product and you have to have the right labor and the right people, you have to have the right supply chain. And the fact that everybody's dependent on a chip, that now the shortage of supply can shut down an industry and cost hundreds of millions of dollars, right, in lost production and lost sales, shows that there's an issue, right, that they should, right, hopefully in most cases, the car companies can combine their buying power and they can buy the same chip. But if they do that, they should buy it from 5 different sources. So if one source, one supplier that I worked for at a time had a fire in a plant, when that fire burned the plant down, you can't afford to shut down different plants. So it's inexcusable that the OEMs didn't understand their supply chain better to let a supplier, and having a chip shortage, shut them down. The supply chain people have to make sure they manage that. And they need to know, because suppliers go bankrupt, suppliers have labor issues where the workforce goes on strike, supplier facilities burn down or have accidents or have an earthquake or a tornado. And when anything like that happens, you can't let it disrupt the rest of the industry. So you either need to have multiple sources, or you need to keep inventory, or you need to have some sort of plan that if you need to, you can bring on new capacity in another way. So this is part of the way where I think the auto industry still has a lot of room to improve and grow.
Thankfully, the countries are starting to see that is a problem. The USA president actually has signed a document where he will finance a few semiconductor facilities in the USA, and the European Union is also looking into it, and China also is doing that. I think that something that actually has, apart from the car industry, has had a lot of problems in other industries.
Right.
Do you consider it feasible to change oil to renewable energy in the automobiles in Latin America countries?
Yeah, I think it's just going to take longer, right? Latin America countries have a lot of oil, right? And they don't have the infrastructure set up right now for possibly hydrogen or for electric vehicles. And that's why I think it's just a question of what the country's priority is and what the country's natural resources are. And then that will drive the longer term plan for where the transition is and where things go. So it's going to, it took a long time to get cars around the world and globally be what they are today. But even if you look at safety standards, they're different between different countries. There's different requirements on vehicles in different regions. So I think like the whole transition from oil to gas to hydrogen to whatever it may be will take time, because countries have good reasons why their rules are the right thing for their country, right? They have the natural resource, or they have a different priority.
Yeah, that's true. And also I think that it will be harder, since most of the countries where the electric vehicles are taking over are where they are manufactured. For example, in Germany or in the USA, that's where they are taking over. And also the infrastructure to do it. For example, I know that in Germany, they use there's electric stations for cars, a lot of electric stations for cars. It will be harder to do it here in Latin America. Well, that's what I think.
Yeah, agreed. I mean, in China, the national government can force down easier. That like when they build new construction and they put up a parking garage, there's a mandatory number or percentage of parking spots that have to be electric. In the United States, the government's not allowed to push that, right? They can't force a private parking garage to offer so many electric vehicle parking spots. In China, the government makes it mandatory, and that helps the adoption of it. So it's different countries, different laws, different strengths of government, different market wants. City of Shanghai and Beijing, the pollution's terrible. If you live in Montana in the United States, there's no pollution problem. People there don't care about electric cars, right? They like their gas-powered trucks that they've always driven, and they don't see a reason why they should switch.
Right. Though I know that in the USA, there's a kind of government helps you with money to buy electric cars, if I'm not wrong.
The government gives a rebate. Yeah, the government gives you a tax refund or rebate if you buy an electric car.
Also, has the automotive industry undergone changes with the pandemic that the world is currently experiencing? If yes, what are those changes?
So the surprising thing with COVID is that there's a lot of places in the world where people were dependent on public transportation, but now because of COVID, people want to be able to travel on their own. So I think car sales in some of the cities and some of the urban areas where people were dependent on mass transportation, now they're thinking that they want to drive themselves, but people are also maybe able to work from home, and congestion is going to be a problem. But for most studies that I've read, people are actually buying more cars because they want independent travel to keep themselves healthy. And then I think there's some car companies that have come out with now, they've always had like cabin air filters, but they're having things that are like antiviral filters or special lighting in the inside of the vehicle that kills viruses. So it opened up a different set of opportunities to create a more healthy environment inside a vehicle.
Right. Well, that's true. It isn't shows the automotive industry that's done that. Actually, I think that most of the places where a lot of people go are doing that. But
Yeah.
do you think Colombia has a potential the design and production of automobiles and not only for assembling them?
For sure. Yep. I mean, I think that now, since the industry is going through this big disruption in Colombia, we just need to pick what area does it want to work, right? I wouldn't recommend, if you're going to start a new auto industry, you wouldn't want to start with an old technology, but what technology do they want to start with? If it's complete vehicle design, or is it on a fuel cell, or is it on battery electric? And then a lot of times the national government would put an incentive that a company that engineers and designs their vehicles locally that then sells them in that region, they're maybe tax exempt or they get taxed at a lower rate. So the government can support it and make it happen.
All right. So it does depend of the government policies.
Yeah, I think it's very hard to do without some level of government support, because other countries do provide government support. So just to level the playing field, I think you'd want some level of support from the government.
Can a mechanical engineer without any postgraduate work in the automotive industry, I'll say it again. Can a mechanical engineer without any postgraduate work in the automotive industry, actually that's work in the automotive industry, or does it require any further study?
Yeah, I think that for me, right, it's always about hiring somebody that has the right work ethic. So if you can tell that the person's going to work hard, if the person's willing to learn because they don't have the experience and they're going to make the effort to learn, then they come in and they can be an entry-level person and they can quickly learn and do better and work their way up. But everybody has to be aware that everybody started at some point with no experience, right? So I came in the auto industry, I had no experience. I was very lucky to be on a training program. I worked with engineers that were very patient. They taught me a lot. Even though I thought I knew a lot about engineering, I didn't really know what an engineer did in automotive until I worked in automotive, right? So I definitely don't think you need the experience. You just need the right attitude, and then you need some basic skills, right? School teaches you how to learn. It teaches you how to apply what you learn. It really doesn't teach. I don't know how much I used of what I learned in school at my job day in and day out, but I did learn the process of learning, solving problems, working with people, communicating, studying online, right? If I don't know something, how do I pick it up and learning it? So you have all those skills that are needed to be an engineer in automotive, even if you haven't designed an automotive part before. I'm sure you're capable of reading a bunch of requirements, looking what others have done to satisfy those requirements, studying what they did, figuring out why they did what they did, and then figuring out a way to make the part the same or better or different. So I would say as an entry-level engineer, you're more than qualified.
All right. Actually, something that you said resonated in me. That you say that you don't even know what percentage of the things you learn at the school you use now, and that's something that I think most of the students that study engineering
Right.
think. What am I learning from? What does it work with? Why does what is the use of what I learn?
Right.
Most of the time we don't know. For example, what is the use? For example, I'm studying mechanical engineering. What is the use of learning exergy, for example, in thermodynamics? I don't know, but that's something that you have to know. Maybe you'll use it, but maybe you don't. But that's something that teaches you how to learn, like you said.
Right. I mean, I took heat transfer, I took thermodynamics, I took material science, I took vibrations. I mean, when I took CAE classes, I had to write the formulas myself to write my own code. I've never really even been able to use CAE software at work because there's always been somebody that has the expertise to do it. But being an engineer, I think it qualifies you to do almost anything, right? Because you learn a thought process, you learn a learning ability, you learn a way to work with people, solve problems, understand what needs to be done. And you do need to learn thermodynamics, you do need to learn heat transfer, you do need to learn controls, circuit design, to kind of be able to think that way, to be a good engineer, even if you don't use the actual course material.
Another question that I have is, of the countries in which you have lived, which do you consider to be the most developed in the automotive industry?
It's hard, right? Because I've done work in Canada, the US, Mexico, Brazil, Argentina, Germany, Portugal, China, India, like a lot of different countries. And each of them are developed in certain ways, right? That one's stronger than the other. China, the thing that I like the most is the consumers are willing to accept new technology, and it doesn't even need to be 90% effective. They just want whatever's new, and they'll take the risk and they'll figure it out and they'll make it happen. So that's great. In Germany, the engineers I worked with are probably the most methodical, that if it's not 100% and it's not perfect and it's not over-engineered and have a factor of safety, they don't do it. China also does the most based on looking at what others do to see if they can look at what others have done and make it better. I think America's kind of in the middle. People, they want to do things that are innovative, but they're not as aggressive as like they are in China. Japan, I did a lot of work with Mazda. They stick to a long-term plan, and they're probably the most, they're very good engineers, and they work their way up very vertically. So each really has its own strengths and weaknesses.
All right. What are the main differences in the design production processes between Ford and Nissan?
So I don't know too much about Nissan. I know a lot about Ford, but I would guess that Ford and Nissan, in terms of like their production processes, are probably fairly similar. From benchmarking that I've seen of their different vehicles, I think that they take a similar approach to development and production.
Right. What do you expect of the automotive industry in the next 10 to 20 years?
I think it's going to become more electronic and less mechanical as much as possible. People are going to do things electronically. I think it's going to become much more responsible in terms of what we talked about before for environmental and social type of things. And I think it's going to become much more integrated with all the other types of industries, be it consumer electronics, entertainment, education, health and wellness. The car is just going to find a way to become more and more a part of your life, kind of like your phone, right? You call it a phone, but people don't use it as a phone. They use it for data. They use it for texting. They use it for social networking, social media. They use it for everything but a phone, but they still call it a phone. And I think the car is going to become something like that too. You'll call it a car because it's what it used to be, but it's going to be providing you entertainment. It's going to provide transportation. It's going to provide you weather. It's going to check your heart rate when you get in it. It's going to know if you're drowsy or not. It's going to tell you that, where you can order your food and have your food, pick up your food for you on your way. It's going to have your packages delivered to it. So it's going to become like an appliance that does all those things in the next 10 years, not just, they'll call it a car, even though it doesn't, it's used for a lot more than just being a car.
Actually, about the things you said, some time ago, Tesla released the specs for their new Model S, and they actually say that the computer that's going to be inside the car is going to be very, very powerful. Something like going to be like mid-range today. Something that's going to be in a car in 1 or 2 years. That's, I think, quite impressive. Don't you think so?
Yeah, I think the computing power in a car today, it's mind-boggling, right? The amount of computing power and the amount of code and the amount of artificial intelligence that's in a car to help make sure that you're safe, help make sure that the car does what you want it to do before you even think about it.
Right. Now for a little bit of informal questions. Do you have any favorite car?
I typically like German cars. I like BMW and I like Porsches for my personal cars.
All right. I don't know if Santiago has any other questions.
Yes, Jerry. Which is your favorite type of engine design?
Hey, I guess I'm old-fashioned, but so I still would prefer like a V6 or a V8 with some kind of boost, right? A turbo or a supercharger. At the same time, I guess I'm being converted to electric. I like the power and performance that you get out of electric vehicle. I don't like the lack of feedback that you get. I feel like that, I don't enjoy it as much, right? Because I enjoy driving. So I like in a gas powered car, the ability to shift gears, the ability to control the car. Whereas an electric car, I feel like you're more removed from it. So it's not my personal style right now, but I'm guessing as I get more used to it, it'll probably become more my style.
And actually, an example that is the sound. The electric engines are really, really silent in comparison to internal combustion engines. Actually, that's something I prefer, but I think that you prefer the feedback that they give. I think you might like the sound, right?
Right. I do. I personally, I like the sound of a car, and I don't want it to be loud. But I mean, if you drive a Ferrari, if you drive a Porsche, there's a lot of times people will drive the car without the radio on because they like listening to their car. I don't think anybody does that in an electric car, right? So it's a different type of experience. And with an electric car, I mean, the torque all on and stuff like that. I mean, it's great, right? I think at the end of the day, the overall performance of an electric car for acceleration, handling, the low center of gravity will probably be one of the best, if not the best powertrain technology. But depending on who you are as a driver, I don't need a manual transmission anymore because I do prefer an automatic, and I think an automatic can control better. But I like kind of feeling a car shift. I like knowing, hearing the acceleration of the car, being able to play with the throttle to get it to shift the different gears. But that's just my style of driving. It's also why I pick the brands that I pick, right? Everybody makes good cars, but they make them for different people.
Yeah, Jerry, that's totally right. I have this story. Last year, one of my best friends got himself a BMW M3. I think it was 2003. One of my favorite BMWs, and one of the best part of being on that car was putting the windows down and just hear the engine sucking the air. It was beautiful. You mentioned that one of your favorite brands was Porsche. Do you ever have one Porsche?
So I did, and I recently got rid of it, but I had a Cayman S because I think if you drive a mid-engine vehicle, it's kind of like why people like a battery electric vehicle, because the center of gravity, right, and the center of the mass is in the center of the vehicle. So once you drive a mid-engine vehicle, and I know the new Corvette's also mid-engine, but the Cayman's mid-engine, Teslas are kind of that way. If they're all-wheel drive and they have the big battery pack, you'll never go back. The steering, the handling, the car's so rock solid, you'll never want to go to a front engine or rear engine vehicle. My opinion.
I think the same way. That's with most car brands. I mean, Porsche did that with the Carrera GT, the Porsche Carrera GT, which it was completely mechanical. It did have any electrical aids, I think it's said that way. And it was a very nice car. But
it's also like the Toyota MR2, right? The Toyota MR2 is a mid-engine vehicle. So it's a different type of driving experience. And if you enjoy driving and you're not just using the car to get you from somewhere, I think most people would prefer a mid-engine vehicle. And they wouldn't know why they enjoy it more, but it's all just about the weight being in the middle of the four wheels versus hung out in front or hung towards the back.
Okay, another question. Which is your favorite JDM?
JDM?
Japanese domestic market.
On the Japanese side? Yeah, probably Honda or Acura, right? Which are really the same. I just think that the Honda Acura performance is most consistent with what I enjoy.
So you are a front wheel drive.
No, the Acura NSX.
Oh, the Acura NSX.
The NSX would be my preferred one, but yeah.
I was thinking about the Civic, but I didn't remember the NSX. That's a very good car.
The NSX, yeah. But I mean, Nissan's got good vehicles too, right? The 300C, the Infinity brand has a lot of high-end performance vehicles. Toyota, the new Supra, I haven't driven one of the new Supras, but it gets good reviews. I think it's built though on a BMW platform, right? The Supra, they share a platform with BMW. So I think everybody makes good vehicles. Again, it depends on what are your priorities.
I've heard that the new Supra, they do a lot of comparison with the M3, the new M3.
Yeah.
They say that they are basically the same, but they look different.
Mm-hmm. I mean, the Japanese companies, typically domestics, right? They have some of the highest quality, long-term durability and reliability of anything on the road. So kind of hard to complain.
Okay, Jerry, so now we're going to do the closure. So Kevin, turn on your camera so we can say goodbye to Jerry. I'm going to do this part in Spanish. Bueno, Jerry, muchas gracias por este tiempo que nos ha regalado. De verdad que ha sido bastante enriquecedor para nosotros conocer más sobre estos temas de la industria automotriz y deseamos que sigas teniendo éxitos en tu carrera.
Also, for my part, thank you very much. We really love having you here with us. Surely this interview will help inspire future engineers, and also thank the support staff present for collaborating in conducting the interview, as well as my co-host.
Great. Thank you. Thank you all. It was nice to meet you. If you have any follow-up questions, feel free to reach out at any time.
Okay, thank you, Jerry.
Thank you. Have a good day. Good night.
Jerry, if you can stay a little while extra, so
Sure.
Sergio, ya puedes dejar de grabar. We will cut this part in the edition of the interview.